Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about the cavitation damage. Introduction. What is the cavitation damage? Cavitation is a phenomenon in which rapid change of pressure in a liquid lead to a formation of small vapor filled cavities in places where the pressure is relatively low. Cavitation is a significant cause of wear in some engineering contents, collapsing what that implode near to a metal surface, cause cyclic stress through repeated implosion. The result in surface fatigue of the metal, causing a type of wear also called cavitation. The most common example of the kind of wear are two pump impellers, sudden change in the direction of liquid occur. Cavitation is usually divided into two classes of behavior: initial or transient cavitation and non-inertial cavitation. The process in which a void or bubble in a liquid rapidly collapses, producing a shock wave, is called inertial cavitation. The inertial cavitation occur in nature in the strata of mantis shrimp and pistol shrimp, as well as in the vascular tissues of plants. In man-made object, it can occur in control with pump, propeller and impeller. Second type is non-inertial cavitation. It's the process in which a bubble in a fluid is forced to oscillate in size or shape due to some form of energy input, such an acoustic field. Such cavitation is often employed in ultrasonic cleaning baths and can also be observed in pump, propeller and etc.
Next, I will explain about mechanism how cavitation damage occur. Any liquid will contain either gases or vaporous bubbles, which serve as the cavitation nuclei. When the pressure is reduced to a certain level, bubbles become the repository of vapor or of dissolved gases. Okay, let me simply say. With vapor bubbles in the low pressure zones of the pump, the motor's energy is wasted expanding the bubbles instead of bringing more liquid into the pump. As the bubble pass into the pump's high pressure zone, the motor's energy is wasted compressing the bubble instead of expelling the liquid from the pump.
Bubbles can collapse as they pass from low to high pressure zones in the pump. When vapor bubbles collapse inside the pump, the liquid strikes the metal parts at the speed of sound. The noise generated from these collisions of gas bubbles into the metal parts of pump sounds like pumping marbles and stones. Cavitation of a pump can be a serious obstacle to smooth operation of a centrifugal pump. Therefore, it is important to understand different pump cavitation causes in order to understand how to prevent pump cavitation.
So, how is it possible that the pressure becomes very low and causing cavitation damage to the ship propeller? When the blade of a ship propeller moves through water, there is a high pressure to the side facing the flow and a lower pressure on the opposite side. As the ship propeller spins quickly, it left trillion bubbles behind it. These bubbles are not filled with air but with steam. The steam is produced by sea water boiling, and the formation of bubbles depends on how fast the propeller rotates. The faster the propeller rotates, the greater risk of forming cavitation damage.
I would like to talk about the causes of cavitational corrosion. So basically, how does it happen? So basically, cavitational corrosion are caused by a microburst of a bubble. Hey, hold your horses, not that kind of bubble. Let me explain to you. So now you may wondering how a bubble can damage a metal. The bubble can damage the metal through its concentrated impact. Even high-strength material can be damaged by the implosion. Releases energy in a very short time, concentrated in a very small spot. If the microjet hits a surface, it damages the material by localized short-term overstrating the material. There are few examples of damaged surface caused by cavitation. These are the images of impeller having continuously exposed to cavitation during 6 months, 12 months, and 24 months. The new impeller shows the geometry as it should be under normal operation without cavitation. After exposed with cavitation, the next 6 months, we can see that corrosion start happening at the center of the wheel, and the impeller plate are damaged. After a year of operation under cavitation, the damaged geometry has a different shape and therefore affect the flow patterns, cause material break off at the top edge of a blade. After 2 years, the blade now been eroded completely, which makes it impossible for the pump to function. So how does the cavitation bubbles are formed? Now let's take a look at this phase diagram, which can help us analyzing this narrow pipe section. The temperature of a flowing water can be 20 degrees Celsius, which is a vertical line in the phase diagram. It crosses the way pressure line at an absolute pressure of 2300 Pascal. As long as the pressure is higher, water remains liquid. If the absolute pressure decreases below 2300 Pascal, water evaporates. The color on the left visualization corresponds to the color indicated on the vertical axis of a phase diagram, and the right upstream of a restriction, the static pressure is well above a vapor pressure. A static in the flow decreases as a flow reaches a narrow pipe section. The pressure at the exposed edge is below the vapor pressure. Consequently, wet water evaporates and cavitation bubbles are formed. And that's about it, the causes of cavitational corrosion. So let's move on to the way how to prevent the cavitational corrosion.
How to prevent cavitation damage? First, focus on flooded suction. Flooded suction occurs when a pump can leverage gravity and atmosphere pressure to push fluid into the pump rather than the pump having to pull, suck and draw the fluid in. When flooded suction occurs, it's virtually impossible for cavitation to occur. A hydraulic equipment expert can determine the exact place to mount the pump to create flooded suction. Next, keep the reservoir clean. Racks, tools, and even cell phone can all find their way into reservoir. When they do, they block the suction tube, creating extreme pressure and causing cavitation. Next, invest in quality oil. Generally speaking, synthetic hydraulic fluid is thinner than those better for preventing cavitation, but it also costs more. However, the cost of high quality oil is a relative drop in the bucket compared to the cost of replacing an entire system. Next, keep oil hot. Don't underestimate the value of tank heater for industrial and mobile hydraulic system. Cool oil causes cavitation, so warming oil prior to use is crucial.
Okay, that's all from us. Thank you.